Okay, welcome. Yesterday we had to do some area between curves, and I want to continue that work today with that new assignment that I posted on Google Classroom. But I want to show you how today I'm going to let you use Desmos to help expedite this process. So I'm looking at number 4 from yesterday, and there's a few interesting aspects to this particular region, or regions if you will. And so I'm going to point those out and then show you how we can use Desmos to make things a little faster. And then when you work on today's assignment, you're welcome to use Desmos to do all the calculations after you set up your definite integrals. So take a look at this region. We have two functions. We have f of theta, which is just cosine of theta, and we have g of theta, which is the horizontal line, 0.5. And it really breaks into two regions here. I'm going to call this region 1, and I'll call this region 2. So this region over here has a top boundary of the orange function f and a bottom boundary of the blue function g. And then this region here has a top boundary of the blue line g, and the bottom boundary is the orange line f of theta. Now, together these regions are drawn over the interval from 0 to pi. And that's fine, but in order to do this problem, we're going to have to break it into two definite integrals, and we need to know this point. So algebraically, we would have to solve cosine theta equals 0.5, which is a very simple unit circle calculation. But let's say you're a little groggy on a snow day and you want to be sure. So you can use Desmos to find that as well. So what I've done over on the next slide here, let's see if I can switch apps real quick. It's not going to let me do that. There it goes. Come on, baby. Fire up. Here we go. I have it saved somewhere here, number 4. Yes. So here's the graphs of these two functions. I haven't shaded the regions yet. I can kind of show you how to do that in a minute. The way we limit the domain on these is we add those curly braces with the interval written in inequality notation to the right. And so I've got my green, which is G, and my blue, which is F. I suppose we could change these colors. Let's make the cosine one orange, and we'll make the G blue. That way it looks just like the picture from before. By the way, if you want to save your work that you do in Desmos, you just have to log in with your school Google, and then you can hit save, and it'll save your graphs. I've got a gazillion graphs that I've worked on over the years saved here. Okay, so I brought you over here so that you could quickly find the intersection of these two graphs so that we can see the region. And the way we do that is simply tap the intersection point, and we see that pi over 3 is the intersection, which would be the solution if you solved cosine theta equals 0.5. Okay, now back to the other screen here. Let's now talk about setting these definite integrals up so that we can use Desmos to compute these. All right, so check it out. We are going to have two definite integrals. For region 1, I'll do that one first. For region 1, orange is on top. So that's going to be the definite integral. And that region starts at 0 and ends at pi over 3, that value that we just computed. So from 0 to pi over 3, we're going to do f on top. So it's f of theta minus g on bottom, which is g of theta, right, the 0.5. And then d theta is our differential there. That's for region 1. For region 2, you'll notice the roles change. And that region starts on the left at pi over 3. And where does that end? It ends at pi because of this interval here, right? So that ends at pi. I almost freaked out when I looked on here. I'm like, hey, where's that line? But that's at pi. And that's going to be g of theta. Oops. Okay, we'll write it like that. Minus f of theta. And that's d theta. And then to get the total area here, we just do 1 plus 2, region 1 plus region 2. And we can do all of this right on Desmos. So I'm going to switch back over to Desmos. I'm going to type in this equation with these integrals, and we'll get the answer. It'll pop out to us. Okay, let me see if I can switch apps here real quick and get this done. So here we are. Now, since I've already typed in f and g, I can use those names when I write out this work. So I'm going to start a new entry here. If you want an integral and you're working on your phone or your other device, you can click functions and then scroll down to calculus, and there's the integral sign. If you're on a keyboard with a computer, just type int and this will pop up. So we said this first one goes from 0 to pi over 3. So you got to do pi divided by 3 and it'll pop up there. And then we said this one had, as you can see here, f on top. So I'm going to do f of x. I'm going to use x instead of theta just to make my life easier here. So f of x minus g of x, because g is on bottom in our picture there. And as soon as I type dx on the end of this thing, it's going to calculate that first region. But we're not done yet, because we want to add on region 2, which is the integral from pi over 3 to pi. Where's my calculus here? There it is. Pi over 3, so pi divided by 3. And then up here, click up on that sucker and hit pi. And then this time it's going to be g of x minus f of x. Okay, since we already have these names typed in there, I don't have to type cosine x and 0.5. I can just do the f of x and g of x here. And then I'm going to type dx, and this time I will get the actual value here, which it looks like it's about 2.256. And for today's work, you can use that decimal answer, right? We don't need an exact answer on this. So just round it off to 3 decimal places. That's what we do on the AP test. And move on to the next problem. For today, you're just going to set up your definite integrals on decimal or on paper and then type them in on Desmos to get the values. Make sure you put your integrand in parentheses, right? I've got the whole f of x minus g of x in parentheses. You don't have to set it up like this with each function given a name. You could just type it all in at once if you want. That's fine. I just like to kind of keep it organized here. And since I've got your attention, let's just see if we can shade these regions in. To shade a region for region 1 here, well, let's do this. Let's go, the bottom one's g of x, so I'm going to type in g of x. And then I'm going to do less than or equal to y, because the region is shaded up and down, less than or equal to f of x. So that shades the region in there, okay? And then if we want to do the other one, let's do it the other way. Let's see what happens if I do this. F of x less than or equal to y less than or equal to g of x. And that shades the other one. And then if you want to just get them all the same color, you can just go like this and change this to green. I'm going to hit save, and boom, now we've got our pictures there. And yeah, let's go with that. So there's the shaded region. The total area is about 2.256 square units, and we've used Desmos to help us with a couple things. We used it to find this intersection point very quickly. And then we also used it to compute the definite integral without having to do all the antiderivatives, the algebra, and the arithmetic that everybody hates. Not to mention this one would involve unit circle values, which I love and which you absolutely need to be proficient at. But for efficiency's sake, as we practice these area between curves, let's just set them up on paper and then type them in here and not worry about all the calculations. You can do this on your graphing calculator as well, and if you don't know how to do that, do Desmos now, and then we will practice that again soon. Okay, long video, but hopefully you can use this to do your homework quickly. If you need me, you know where to find me. Take care.